Then, about 10 years ago, we decided to build the biggest scientific experiment ever built, 16 miles in circumference underneath Geneva. We accelerate protons, which are these simple particles, to 99.999999% the speed of light. In every collision, we create the conditions that were present less than a billionth of a second after the Big Bang. We take photographs of those 600 million collisions per second, and we discovered a thing called a double pulsar, which is two stars, the mass of the sun, compressed into something about the size of LA.
Underneath the Earth's surface near Geneva, there's a display of human ingenuity, the Large Hadron Collider, a hub for scientific exploration. It has allowed scientists to investigate the subatomic world, leading to the discovery of the God particle a few years ago. Recently, physicist Brian Cox made a concerning announcement that has sent ripples of fear in the scientific community. Something terrifying has been identified at CERN, with potential consequences extending far beyond our imagination. Does our pursuit of knowledge steer us toward an imminent collision with catastrophe? Join us as we plunge into the depths of this scientific mystery. Before delving into the announcement, it's crucial to understand the nature of particle accelerators. The Large Hadron Collider, known as the LHC, constitutes a 17-mile circular arrangement of superconducting magnets and stands as the world's largest and most potent particle accelerator. Under the operation of CERN, it symbolizes the pinnacle of human scientific accomplishment. Remarkably, its power extends to recreating the precise conditions of the universe's inception. However, could this machine, devised to unveil the universe's secrets, harbor the key to something potentially more ominous? Established in 1954, CERN stands as one of the globe's foremost research organizations. With 23 member states and a multitude of scientists, it serves as a central hub for collaborative research and innovative endeavors. The LHC represents CERN's flagship initiative, forming just one facet of an expansive network encompassing accelerators and experiments. Imagine a racetrack, not for conventional vehicles, but for subatomic particles engaged in a race against time and space itself. The LHC propels protons to velocities approaching the speed of light, setting them on a collision trajectory that mirrors the energy conditions during the universe's Big Bang. Traveling at almost the speed of light, the protons complete over 11,000 laps around the ring every second. These collisions generate temperatures surpassing 1,000,000 times the heat of the sun's core. A myriad of magnets guides the protons on their trajectory, while intricate cooling systems maintain the magnets at temperatures colder than outer space. These encompass 1,232 dipole magnets, responsible for bending the beams, and 392 quadrupole magnets, which focus the beams. Just before the collision, an additional type of magnet is employed to squeeze the particles closer together, amplifying the likelihood of collisions. Achieving this collision is comparable to precisely firing two needles 6 miles apart, ensuring they meet halfway. The required precision is staggering, and the technology deployed is unparalleled. The LHC's design showcases remarkable engineering. It comprises two parallel beam lines concealed 574 feet below the surface, safeguarded from the Earth's radiation. In this underground realm, the entire system is chilled to -456 degrees Fahrenheit, colder than the vacuum of space, crucial for the optimal functioning of superconducting magnets. Within the LHC, beams are orchestrated to collide at 4 points around the accelerator ring, aligning with particle detectors ATLAS, CMS, ALICE, and LHCb. Each detector serves a distinct purpose, delving into various facets of particle physics. Together, they function as colossal cameras, capturing snapshots of these collisions. Scientists then sift through the debris, seeking signs of the elusive Higgs boson, also known as the God particle, and clues to the universe's fundamental building blocks. It resembles assembling a cosmic jigsaw puzzle, where pieces are invisible and the picture remains unknown. Studying the microcosm yields insights into the macrocosm. Yet every answer begets a new question, and each discovery brings forth a fresh challenge. The LHC transcends being merely a scientific instrument. It stands as a testament to human curiosity and innovation. It embodies our unyielding pursuit of knowledge and our quest to comprehend the fundamental forces shaping our universe. However, as we push the boundaries of our understanding, we must grapple with ethical and existential questions. What risks accompany probing the unknown? Could our quest for understanding inadvertently unleash uncontrollable forces? Within the esteemed halls of CERN, where the limits of human comprehension are continually pushed, a revelation has surfaced, evoking a sense of unease even among seasoned scientists. Brian Cox, a former CERN researcher and a prominent figure in particle physics, recently delivered an announcement that has captivated and unsettled the world. Cox's words carry an unsettling clarity. The primary objective of CERN's Large Hadron Collider is to replicate a miniature Big Bang. Yes, you heard correctly, a scaled-down version of the very event that gave rise to our universe. The physicist further elucidated the ramifications of this objective, underscoring the LHC's exceptional capacity to unveil new insights. This encompasses its potential to unravel the mysteries of the Higgs boson and delve into dark matter, an enigmatic substance constituting a substantial portion of the universe. Picture wielding the power of creation in your hands, the capability to summon the fundamental essence of the universe. It's an enticing prospect, yet one fraught with peril. The mini Big Bang isn't confined to theoretical musings. It's a tangible reality within the LHC. The temperatures, pressures, and raw energy all replicate the conditions of the universe's infancy. It's akin to standing at the dawn of time, witnessing the genesis of existence itself. However, with such power comes a weighty responsibility, prompting the looming question, what if something goes awry? Indeed, a significant mishap occurred. In 1978, Russian physicist Anatoly Bugorsky faced a calamity that would permanently alter the trajectory of his life. During his work on the U-70 synchrotron at the Institute for High Energy Physics at Protvino, Russia, a malfunction placed Bugorsky's head inadvertently in the direct path of a proton beam. The force of the beam, beyond comprehension, traversed through his skull, entering at the back of his head and exiting through his nose. Bugorsky's encounter was surreal. He witnessed a flash brighter than 1,000 suns, but experienced no pain. Despite the beam causing destruction by burning through tissue and bone, he remained conscious and managed to walk to the clinic for treatment. The aftermath presented a mix of horror and fascination. The beam's trajectory resulted in localized tissue death, causing the loss of hearing in one ear and partial facial paralysis. Astonishingly, Bugorsky's cognitive abilities remained unaffected, allowing him to continue his scientific pursuits. This incident transcends personal tragedy, serving as a cautionary tale that highlights the formidable power and potential hazards associated with particle accelerators. The risks inherent in devices like the LHC should not be underestimated. Concerns within the scientific community regarding unforeseen reactions and the manipulation of the fabric of space and time are not mere elements of science fiction, but genuine apprehensions. The secrets of the universe are not mere playthings. They are the instruments of immense power. One of the most concerning and captivating aspects related to the LHC's experiments is the potential creation of a miniature black hole. Black holes represent regions in space-time where gravity is incredibly strong, preventing even light from escaping. They function as cosmic vacuum cleaners, devouring stars, an enigmatic presence lingering in the shadows of our universe. The notion that the LHC might generate such an entity, even on a microscopic scale, is startling for both the general public and experts. Could this tiny black hole grow uncontrollably, consuming the Earth from within? Although scientists at CERN have affirmed that any generated black hole would be unstable and evaporate almost instantly, the mere possibility has sparked debates, instilled fears, and evoked a sense of awe regarding the power we command. Understanding how the LHC could produce a black hole involves delving into the fundamental mechanics of particle accelerators. When protons collide at nearly the speed of light, the released energy is so immense that it distorts the fabric of space-time itself. Picture a trampoline pulled tight, then imagine a heavy weight dropped onto it. The fabric bends and curves, and if the weight is substantial enough, it could create a depression so profound that nearby objects would be drawn into it. This serves as a simplistic metaphor for the potential occurrences within the LHC. In the realm of quantum physics, where the laws of the universe are both peculiar and exquisite, A theory posits that additional dimensions might be concealed within our reality. If these dimensions exist, collisions at the LHC could potentially access them, forming a gravitational funnel that gives rise to a minuscule black hole. This mysterious interplay of particles has garnered attention from renowned scientists, most notably the late Stephen Hawking. In his work Starmus, he cautioned about a scenario where the Higgs boson could become unstable at exceedingly high energy levels. This instability might result in a catastrophic vacuum decay, an event of cosmic proportions that could annihilate not just Earth, but the entire universe. Sir Martin Rees, a distinguished British cosmologist and astrophysicist, also expressed apprehensions regarding experiments at CERN. In his book, On the Future, Prospects for Humanity, he delved into potential risks linked to particle accelerator experiments, including those conducted at CERN. His words weren't merely a warning. They carried a sense of existential unease. He spoke of a worst-case scenario where an unfortunate experiment could induce a condition termed vacuum instability. Theoretically, this instability could trigger a phase transition that would propagate through the very fabric of space-time. The outcome? A cosmic catastrophe capable of engulfing the entire universe. Rees's apprehensions extended beyond theoretical contemplations. He ascribed a likelihood to these catastrophic scenarios, albeit a low one. Nevertheless, he argued that even a minute probability should cause us to pause. The stakes are exceptionally high, and the margin for error is exceedingly low. The scientists at CERN have computed the probabilities, conducted simulations, and scrutinized theories to advocate for the safety of the LHC. Brian Cox himself acknowledged the significance of responsible exploration, acknowledging widespread fears and concerns surrounding the LHC's activities. However, he stressed the presence of rigorous safety measures, thorough reviews and protocols ensuring the utmost care in the LHC's operations. Cox reassured that the energies involved are well within what the Earth naturally encounters, and the chances of creating a stable black hole are astronomically low. Even if one were formed, scientists assert it would be so minuscule and unstable that it would vanish in a burst of energy, a phenomenon predicted by Stephen Hawking, known as Hawking radiation. It would be a brief moment of cosmic wonder, a glimpse into the abyss, and then cease to exist. Some have ventured further, speculating that the LHC's experiments might open a gateway to another universe or dimension. Although largely dismissed by the scientific community, this notion has captivated the imagination of many, becoming a subject of fascination, fear, and even folklore. What lies beyond our reality? Could we inadvertently unleash forces or entities that we do not understand? The concept of opening a portal to hell has been sensationalized in various media, adding to the uncertainty. But how did this idea originate, and what does it signify in the context of scientific exploration? The notion of parallel dimensions has a history in physics. String theory, a primary contender for a comprehensive theory of everything, suggests the existence of more than the familiar 3 spatial dimensions and 1 temporal dimension. These additional dimensions might exist in compacted or concealed forms, potentially accessible or revealed under extreme circumstances. Envision the LHC as a cosmic key capable of unlocking doors sealed since the dawn of time. When protons collide at unprecedented energies on Earth, they could, in theory, generate disturbances or ruptures in the fabric of space-time. These ruptures could serve as gateways to dimensions beyond our own, resembling cracks in a cosmic barrier that separates us from the unknown. The repercussions would resemble the effect of dropping a stone into a perfectly calm lake. The impact generates ripples, waves that propagate and interact with everything they encounter. In the context of the LHC, these ripples could manifest as disruptions in the dimensions themselves, extending into realms beyond our observable or comprehensible reach. Scientists at CERN promptly emphasized that the energies needed to create such a portal likely exceed the capabilities of the LHC. The idea of opening a gateway to another dimension remains firmly within the realm of science fiction. Nevertheless, the mere contemplation of such possibilities, the exploration of the limits of our understanding, and the gaze into the abyss of the unknown underscore the power of human curiosity and ingenuity. For the scientists at CERN, it should be a quiet indication that certain doors, once opened, may uncover truths that we are unprepared to confront. The experiments conducted by the LHC have not solely prompted scientific and philosophical inquiries, but have also given rise to legal and ethical considerations. The very act of replicating the conditions of the universe's birth, delving into the primal essence of existence and manipulating it with our technological tools, has sparked discussions that go beyond the realm of science. Are we assuming the role of a deity? Are we intruding upon hallowed ground, manipulating forces that were once exclusive to the cosmos? These are not merely rhetorical queries, but profoundly disquieting investigations challenging our fundamental comprehension of ethics and responsibility. The formation of a miniature black hole, for example, isn't merely a scientific fascination, but a potential Pandora's box. Picture a vortex, drawing everything into its inevitable grasp, but on a cosmic magnitude. Some legal scholars and ethicists have questioned whether humanity possesses the right to take such risks, even in the pursuit of knowledge. Lawsuits have been initiated, aiming to halt the LHC's experiments, citing concerns about safety and the potential for catastrophic outcomes. The debates persist, not only in courtrooms, but also in academic corridors, in the media, and around dining tables. In 2008, a legal action was initiated in Hawaii by Walter L. Wagner and Luis Sancho, aiming to halt the LHC's operations. They contended that the collider might generate black holes capable of devouring planets, or unprecedented phenomena that could potentially annihilate not only Earth, but the entire universe. The lawsuit sought a temporary restraining order against CERN, arguing that the organization had neglected to furnish an environmental impact statement, as mandated by U.S. law. While the case was dismissed, it sparked heated debate, bringing the potential risks associated with the LHC into sharp focus. In Germany, a teacher named Otto Rüssler lodged a complaint with the European Court of Human Rights, alleging that the LHC violated the right to life, as guaranteed by the European Convention on Human Rights. Rüssler's apprehensions stemmed from the fear that the LHC could generate microscopic black holes prone to uncontrollable growth. Although both lawsuits ultimately proved unsuccessful, they contributed to a broader wave of concern and skepticism surrounding the LHC, reflecting a profound unease about the unknown, and a fear that our pursuit of knowledge might lead us down an irreversible path. CERN emerged in the aftermath of World War II, a time when the world grappled with the consequences of the conflict. Against this backdrop, a group of forward-thinking scientists envisioned a realm where national boundaries would dissolve, and the pursuit of knowledge would become a beacon of hope. They dreamed of a laboratory, a crucible dedicated to exploring the mysteries of the universe and unlocking the secrets of existence. Thus, CERN was conceived, a product of war and wisdom, symbolizing what humanity could achieve when propelled by curiosity rather than conflict. Over the years, CERN has stood at the forefront of particle physics, significantly contributing to our comprehension of the fundamental forces and particles constituting the universe. The organization has played a pivotal role in various groundbreaking discoveries, including identifying neutral currents and the WNZ bosons, particles pivotal to the weak nuclear force. The Higgs boson, a particle conferring mass to others, existed as a theoretical ghost, a whispered legend in physics. Its presence posed a puzzle, a riddle entwined with the essence of reality. CERN's persistent pursuit of this elusive entity culminated in a moment that reverberated through the scientific community. In 2012, the Large Hadron Collider finally revealed the God particle, a triumph of human ingenuity and the testament to our unyielding quest for knowledge. Yet the Higgs boson isn't the sole enigma under CERN's scrutiny. In a remarkable breakthrough, the LHC uncovered a particle challenging our conventional physics understanding, the pentaquark. Comprising 5 quarks, including an antiquark, this particle deviates starkly from familiar protons and neutrons, each consisting of 3 quarks. Nature hadn't foreseen the existence of such a particle, underscoring the unpredictable nature of the quantum world. The pentaquark's discovery at the Large Hadron Collider in Switzerland marks a new frontier in comprehending the universe. Despite their fleeting existence, a mere 100,000th of a billionth of a second, these particles bear implications with potential eternal significance. They might unlock the secrets of universe formation, the binding of fundamental matter particles, and the operation of the strong force, the adhesive holding atoms together. The pentaquark isn't solitary in its exotic nature. Alongside it, scientists have uncovered tetraquarks, particles composed of 4 quarks. These findings don't merely expand the particle zoo, they reshape our comprehension of it. They enable scientists to categorize these particles akin to elements in the periodic table, laying the groundwork for a novel theory and a new set of rules governing this exotic matter. Furthermore, in May 2023, researchers at CERN achieved another noteworthy breakthrough: the observation of a rare decay of the Higgs boson into 2 muons. These results represent a substantial stride in validating the characteristics of the Higgs boson. It's akin to locating a missing piece within a cosmic jigsaw puzzle, aiding our comprehension of why mass exists. However, the enigmas of the universe remain far from resolved. Just in April, CERN disclosed the identification of a novel particle, smaller than quarks and leptons. This revelation challenges our existing comprehension of particle physics and initiates a new frontier in the pursuit of understanding the fundamental constituents of the universe. In the exploration of these inquiries, CERN scientists find themselves at the forefront of scientific investigation, navigating unexplored territories in the microcosm of particle physics. The endeavor to comprehend the fundamental components of the universe unfolds as an intellectual odyssey, where each discovery serves as a compass pointing toward a deeper understanding of the cosmos. As we observe the cosmos, both on a macro and micro scale, the cosmic dance of celestial bodies and the intricate choreography of subatomic particles converge in a symphony of scientific revelation. CERN's particle accelerators, resembling contemporary alchemical laboratories, propel us into realms where the fabric of space and time unravels, unveiling the fundamental principles governing our reality. The synergy between theoretical frameworks and experimental validations becomes the cornerstone of progress. Theorists develop intricate models to conceptualize the unseen, while experimentalists, armed with state-of-the-art technology, embark on journeys into the quantum realm to test and validate these theories. This delicate interplay between theory and experiment is the crucible in which scientific understanding is forged. However, even as we mark each milestone, the universe remains an expansive canvas of unanswered questions. Dark matter, an elusive cosmic companion, shrouded in mystery, continues to elude our direct detection. The cosmic web, woven by the gravitational threads of dark matter, invites us to decipher its patterns and unravel the cosmic story inscribed in cosmic microwave background radiation. The evolving narrative of scientific discovery at CERN extends beyond the esoteric realm of particle physics alone. It reverberates through interconnected disciplines, from astrophysics to cosmology, presenting a holistic picture of the cosmos. Collaborative efforts transcend borders and institutional boundaries, exemplifying the collective human endeavor to unravel the cosmic enigma. In the tireless pursuit of knowledge, each revelation acts as a stepping stone, propelling humanity further along the path of understanding. The cosmic puzzle, with its myriad pieces scattered across the vastness of space and time, invites us to explore, question, and marvel at the grandeur of the universe. As CERN persists in pushing the boundaries of scientific investigation, each experiment becomes a brushstroke, contributing to the ever-expanding canvas of human knowledge. So this seems enough for today's video. We would love to hear your thoughts on this. Stay tuned for more videos.